Okay, so I told you I would try to create an answer key video for this so that you have access to it while I'm gone. So problem 1, 2 sine of theta plus 1 equals 0. It's kind of like having 2x plus 1 equals 0. Subtract the 1, divide by 2, x is a negative 1/2. X is taking the place of sine of theta. And sine of theta is negative 1/2 at 210 degrees and 330 degrees. If I look at this problem, this is asking us to solve for theta between 0 and 360, so 210 and 330 is exactly what we want. Now, I didn't use any identities, I just did some opposite operations, so that's exactly what the answer is. I'm not worried about checking it on this one. Okay, question 2, cosine squared theta plus 2 cosine theta plus 1 is equal to 0. Okay, it's kind of like having an x squared plus 2x plus 1 equals 0. Factor, shortcut, two things that multiply to 1 but add to 2 are 1 and 1, so x plus 1, x plus 1. Split and solve. X plus 1 equals 0 gives me x equals negative 1, and the other one's the exact same. X took the place of cosine, and cosine is negative 1 at 180 degrees. I'm not always going to switch to the unit circle. Y'all can use the unit circle to determine what you're looking at. Again, I didn't use any sort of identity, nor did I... The big thing when you have to check is when you are squaring both sides. That's the big situation where you really need to make sure that you're checking. Okay. So, cosine of 2 theta plus cosine of theta is equal to 0. I notice my angles are not the same, so I am using an identity here. Cosine of 2 theta, I'm going to look down at my double angle identities, and I have 3 options. Since everything else is cosine, I'm going to use the second option. 2 cosine squared minus 1 is equal to 2 cosine theta. So this replaces with 2 cosine squared theta minus 1. Now keep in mind that when you replace a single term, a monomial, with a binomial, or a double term more accurately for trig, you have to make sure that you're putting things in parentheses and distributing if needed. In this case, it's not needed because of the fact that nothing was happening to cosine of 2 theta. It wasn't squared, it didn't get multiplied by anything, there wasn't a negative in front of it that has to be distributed, it was just there. So this is kind of like having 2x squared minus 1 plus x equals 0. So quadratic equations, we generally like them in standard form to solve, and I'm going to have to do the full AC method here. A times c, the coefficient of x squared times the constant, is 2 times the negative 1, which is negative 2, and two things that multiply to negative 2 but add to 1 are 2 and negative 1. Remember, when you're doing the full AC method, you cannot jump directly to the parentheses. You must do the rewrite. So I have to rewrite this as 2x squared, and I replace this x with a 2x and a negative 1x, because those were the two numbers that I just came across. Then I'm factoring my grouping. 2x, x plus 1, negative 1, x plus 1 equals 0. So 2x minus 1, x plus 1 equal to 0. Split and set them equal to 0. 2x minus 1 equals 0. Add 1, divide by 2. X is 1/2. Subtract 1. X is negative 1. But it wasn't x, it was cosine. Cosine of theta is equal to 1/2. Again, we're between 0 and 360 on this section. So that was true when theta was 60 degrees and 300 degrees. And cosine of theta is equal to a -1 when theta is equal to 180 degrees. I would plug those back in. I would check them, because I did use an identity. For the sake of time on this video, I'm just going to say I checked them. We're good. Okay, question 4. 2 cosine theta equals 1. Well, that means cosine of theta is equal to 1/2, which is at theta equal to 60 degrees and theta equal to 300 degrees. Five has cosine of theta equal to a -√3/2. Hey, I don't have to solve for anything. I just have to find where cosine's -√3/2, which happens to be at 210 degrees and 150 degrees. Okay, next one. Sine of 2 theta is equal to a -√3/2. Now, I could change this one to an identity on this one, but it's not going to help me a whole lot, because 2 sine of theta cosine of theta equal to -√3/2. I could divide by the 2. I'd get sine of theta cosine of theta equal to -√3/4, but this is not our best option. It's not our best option because there's nothing we can really do that's great from there. You can kind of do a guess and check of when the product of those two is a -4. But it's easier instead to continue to work with the sine of 2 theta because it is the only angle there, so it's not terrible to work with. In order to do it, you have to recognize a couple things. First off, you can do inverse trig right away. It works. You get 2 theta equal to sine is -√3/2 at 240 degrees, as well as at 300 degrees. Okay, but the thing you have to be careful of with this, when you're working with 2 theta instead of theta, your range for theta has changed. Theta, which was originally between 0 degrees and 360 degrees, inclusive of both. To get to 2 theta, I'm doubling all of that. So now 2 theta is between 0 degrees and 720 degrees. So that means I need to do coterminals to these as well. 2 theta could be equal to 240 plus 360 is 600. 300 plus 360 is 660. And I do that when they're still in the 2 theta form, and then I divide by 2 to get my thetas. Theta is 120. Theta is 150. Theta is 300. Theta is 330. I plug them back in and I check them and they all work out. Okay, question 7. cosine 2 theta equals 8 minus 15 sine of theta. Okay, so I see my angles that are not just theta, but I've got more than one angle here, so I have to do an identity now. It's not like the last one where I could just work with the 2 theta because it was only 2 theta. This one I have to use an identity. I notice that the other thing left in this equation, other than the cosine of 2 theta, is sines. So the identity that works with sine is that one. So 1 minus 2 sine squared theta equals 8 minus 15 sine of theta. Okay, that's like 1 minus 2x squared is equal to 8 minus 15x. It's quadratic. I need it equal to 0 to solve. I want the 2x squared to be positive. So I'm adding 2x squared and subtracting 1 from both sides. 0 is left over here, and I'm going to put this in standard form. So 2x squared is positive, negative 15x, and plus 7. Full AC method ahead. 2 times 7 is 14. Two things that multiply to 14 but add to a negative 15 are negative 1 and negative 14. So this is a full AC method, so you must do the rewrite. 2x squared minus x minus 14x plus 7. And factor out the halves. I get x, which leaves me with 2x minus 1. A negative 2, because... Not a negative 2, what am I thinking? Negative 7, because I want the 2x that's left to be positive, and the 1 to be negative. So I get x minus 7, and 2x minus 1. So, split and solve, x equals 7. Add 1, divide by 2, x is 1/2. But x was taking the place of sine, and sine will never be 7. So sine equal to 1/2. Sine is 1/2 at, what's our root? We're still doing degrees between 0 and 360, so sine is 1/2 at 30 degrees and at 150 degrees. Plug them both back in, they both work. Sweet.
I was just going to feed you.
Okay. Ooh, this one's different. Sine of theta plus cosine of theta is equal to 1. When I look at this one, there is no easy way to change sines into cosines or vice versa, so that's definitely not going to be a thing. And there's no identity that connects sines to cosine without bringing tangent involved or changing angles, which means I have to take a different approach. This is that situation where this would be so much easier if the sine and the cosine were squareds. So that's what I'm going to do. I'm going to square them. If I square one side of the equation, I square the other, and you have to make sure you're squaring the entire thing. So sine plus cosine getting multiplied by sine plus cosine equal to 1. I FOIL it out. Sine times sine is sine squared. Sine times cosine is sine cosine. Cosine times sine is sine cosine. And cosine times cosine is cosine squared. I keep in mind that it doesn't matter the order in which I add things. So this sine squared plus this cosine squared over here is going to be 1. Sine plus cosine is 2 sine cosine. Sorry, sine plus cosine plus sine. Sorry. Oh my goodness, words. Sine cosine plus sine cosine is 2 sine cosine. I think I said it wrong the first time. I know I said it wrong the second and third time. Okay. Well, I combine like terms. I subtract the 1. I get 2 sine theta cosine theta equal to 0. Now, this would not be something I would like to see except for the fact that it's equal to 0. And given that it is equal to 0, this is doable. Because if I divide by the 2, I still get sine cosine equals 0. And I can now split. Sine times cosine is only 0 if sine is 0 or cosine is 0. Sine is 0 between 0 and 360 at 0 degrees. Don't forget the 360 degrees as well, and 180 degrees. And cosine of theta is 0 at 90 degrees and 270 degrees. And this is the big situation where you gotta make sure that you're checking. Because if you're checking your answers and that does not work, you're gonna get stuff wrong. So remember, the original problem was sine plus cosine equals 1. So starting with the 0 degree angle. Sine at 0 degrees is 0, cosine at 0 degrees is 1, equal to 1. That one works. And if 0 degrees, 360 has to work. If one works, the other one has to work when they're coterminal. So that one's good. At 180 degrees, sine of theta is -1. No. Sine of theta is 0. What am I doing? Cosine of theta is -1, which it's supposed to be equal to 1, and that's not true, so 180 is an extraneous solution. At 90 degrees, sine is 1 and cosine is 0. That does add up to 1. At 270 degrees, sine is -1 and cosine 0, which is not equal to 1. So, that one doesn't work. Okay, question 9. 4 sine squared theta equal, no, not equal, -1 equals 0. It's like having 4x squared minus 1 equals 0. Add the 1. 4x squared equals 1. Divide by 4. X squared equals 1/4. To get rid of a squared, I take the square root. Remembering that when I take the square root, I need a plus or a minus. To square root a fraction, I square at the top, I square at the bottom. A lot of people have been looking at a problem like this lately and rationalizing the denominator, which, great, I'm glad you rationalized the denominator. Beautiful. But the square root of 4 is just 2, and save yourself the work. Please just write 2. Square root of 1/4 is 1/2. So, that took the place of sine. Ooh, don't mind the helicopter going above me. Not sure how well you can hear that, but... Okay, anyway. Sine of theta is a positive and negative 1/2 at... Okay, what are we looking at here? All theta in radians. So, sine is a positive 1/2 at pi over 6. Oh, why did I write sine of theta equals pi over 6? Sine of theta is positive negative 1/2. Theta equals pi over 6. 5 pi over 6 is also where sine is positive 1/2. It's a negative 1/2 at 7 pi over 6. And at 11 pi over 6. Now, I want for all theta in radians, which means I'm taking all of these answers and saying plus 2k, not 2k, plus 2 pi k, because a full circle, where k is an integer, plus 2 pi k, where k is an integer, plus 2 pi k, where k is an integer, plus 2 pi k, where k is an integer. So, there's question 9. Last one in this first chunk of problems is question 10. Which is 2 cosine squared theta equal to 1. Divide by 2. Take the square root. positive and negative square root of 1/2 is positive and negative 1 over the square root of 2. Rationalize my denominator, I get a positive or negative square root of 2 over 2. Okay. Happens for cosine at pi over 4. 3 pi over 4. Why am I writing cosine of theta again? Don't do that. Don't follow me on doing that. I'm doing dumb things. Let's try this again. Theta equals pi over 4. Theta equals 3 pi over 4. Theta equals 5 pi over 4. Theta equals 7 pi over 4. Again, plus 2 pi k, where k is an integer. Oh, that's a funky looking z. That's okay. I struggle to write the double barred z at times because it's weird. Now, if you are a person who likes to simplify down your answers, you'll notice that on the unit circle, each one of these angles is a quarter, or it's like halfway between our general quarter marks, and so they're all a quarter apart. So we could have simplified this down. Like, don't get me wrong, you can leave that as your final answer. Or you could have simplified this down to pi over 4 plus a quarter of a circle is a pi over 2k, where k is an integer. You don't have to do that. It's just an option. What's my next problem in the set? 13. Cosine 2 theta plus 4 cosine theta is equal to a negative 3. Okay, so I'm going to be using an identity here because of the fact that I have theta and I have 2 thetas. I don't like having that. It's cosine of 2 theta. So since everything else in the problem is cosines, I'm going to use this one. It says 2 cosine squared theta minus 1. Pull, pull, pull. Sorry, that was not to you guys. That's to my little cousin. So 2 cosine squared theta minus 1 plus 4 cosine theta equal to negative 3. Okay, we got quadratic again. 2x squared minus 1 plus 4x is equal to a negative 3. 2x squared plus 4x. I add the 3 to both sides. I get plus 2 equals 0. Now my brain says, oh crap, I might have to do the AC method, except I could do a greatest common factor first. Saved me the AC method. Now I just have to look for 2 things that multiply to 1 and add to 2, which are 1 and 1. So x plus 1 and x plus 1. Split and solve, set equal to 0, x is negative 1. Remember that when you are solving a quadratic equation, that greatest common factor, if it is an integer and not a variable, it has no effect whatsoever on the solution. Because you can divide that 2 out, and 0 divided by 2 is still 0. And you do that before you split. Okay, so x is negative 1, except it was never x, it was cosine. And cosine of theta is negative 1 at 180 degrees, or for this one, I'm looking at all theta in radians. So pi, and then don't forget it's pi plus 2 pi k, where k is an integer. Okay, 15 through 18 is the next set. cosine of 2 theta minus sine squared plus 2 equals 0. So cosine of 2 theta. Again, there's the 3 different identities that work for it. Since everything else in the problem is sines, I'm going to use the sine one, which is 1 minus 2 sine squared. Minus sine squared plus 2 equals 0. Well, that looks like fun. 1 minus 3 sine squared theta plus 2 equals 0. In fact, actually, this one's not so terrible, because when I combine my like terms, I only have sine squared. I don't have to worry about factoring. Yay! Subtract the 3 from both sides. I get negative 3 sine squared is negative 3. Divide by negative 3. Sine squared is equal to 1. Take the square root, remembering you need positive and negative, and the square root of 1 is 1, so it's where sine is positive or negative 1. Sine is a positive or negative 1 at 90 and 270. And we're back into degrees, but it's for all theta in degrees. Before I start adding the 360k, I'm going to plug these back in, make sure they both work. Cosine of 2 times 90 is cosine of 180, which is negative 1. Sine squared of 90 degrees is 1. So, negative 1 plus 1 plus 2 equals 0. That doesn't work. But okay, I think I did something wrong there, because I think that one's supposed to work. Okay, this is cosine of 180 degrees, which is negative 1. Sine of 90 is 1. Squared is 1. Okay, yep. I made a mistake in my calculating. Negative 1 minus 1 plus 2 is indeed 0. Okay, so 90 works. Plus 360k. K is an integer. Helps if I plug this into a calculator, but I didn't bring a calculator with me, so I'm just doing it all in my head. Okay, so 270. 270 times 2 is 540, which is coterminal to...
But there's a missing number somewhere.
Yep. Negative 1 minus 200 sine of 270 squared. Sine of 270 is negative 1. Square that is positive 1, and it's still a minus in the equation. Plus 2 equals 0. 0 equals 0 again.
You bring this home, like they do what they work on as a group.
Okay, so that was 15. That's what we're doing. We're 15 through 18. Okay. Question 16. Sine squared theta minus sine of theta is equal to 1. Not 1, equal to 0. Okay, this is quadratic, but it's equal to 0. So think of this as x squared minus x equals 0. I've been moving away from using the x's for a bit, but let's go back. Okay, greatest common factor is x, leaving me with an x minus 1. X is 0. X minus 1 equals 0 gives me x is 1. So I got sine is 0 and sine is 1. Sine is 0. And this is for all theta in degrees at 0 degrees. Now I don't need the 360 here because the 360 is coterminal. I typically would if I said between 0 and 360, but since we're going to be adding the 360 degree K, 360 is taken care of. If you do it, it's not the end of the world, it's just redundant. Okay, sine is also 0 at 180 degrees. Sine, oh, why did I write 0 here? Sine is 1 at 90 degrees. Okay, So plug these back in, and yep, they all work. So plus 360k, k is an integer. Plus 360 degree k is an integer. Plus 360 degree k is an integer. Now again, this is one that could have been simplified down. Now, not all of it, because while you might say, oh, they're only 90 degrees apart, that is true, but if you start trying to simplify all three of them together, you're going to get the 270 degree angle in there as well, which doesn't work. So you can simplify the 0 and 180 to be 0 plus 180k, or k is an integer, or you just leave it like this. 17, 2, whoa, I'm clicking things. 2 sine squared theta minus 1 equals 0. I add 1. I divide by 2. I take the square root. Square root of fraction, you square at the top, you square at the bottom. So theta equals, don't forget your plus or minus. Square root of 1 is 1. Square root of 2 is square root of 2, which is positive or negative square root of 2 over 2. Okay, this is for all theta in degrees. So sine is square root of 2 over 2 at 45 and at 135. It's a negative square root of 2 over 2 at 225 and 315. They all work, so plus 360 degree k is an integer. 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 Again, this one could be simplified down. I'm not going to continue to write that out, though. If you simplify it down, great. 18. Cosine theta minus 2 cosine theta sine theta. Why did I write sine first? You saw nothing. I didn't do it. Equals 0.
Hit the window. I'm like, oh, did it knock itself
Okay.
away? It flew away. Okay.
So I've got something that looks like this. X minus 2xy equals 0. I'm going to factor out an x, leaving me with 1 minus 2y equals 0. Sweet. Remember, this only works when it's equal to 0, but it is equal to 0, so sweet. I know that was a little redundant, but it's okay. 1 minus 2y equals 0. Subtract 1, divide by a negative 2y is 1/2. Now, x took the place of cosine.
If I didn't screw it together first.
Cosine is 0 at 90 degrees and 270 degrees. Sine of theta is equal to 1/2. Sine is 1/2 at 30 degrees and 150 degrees. Plus 360 degree k. K is an integer. Plus 360 degree k. K is an integer. Yes, those two can be simplified down to 90 plus 180k. Plus 360 degree k. K is an integer. Plus 360 degree k. Guess what? K is still an integer. It's almost like it's always an integer. Oh, wait. It is. And yet I mean and make you write it out every single time. How dare I? Okay. 20, 23 through 25, and 38. Okay. Question 20. Sine of theta minus tangent theta is equal to 0. I notice this is equal to 0, which makes me happy because I also notice I can factor this. Because this is kind of like xy minus y equals 0. I can factor out a lot. Y. Split and solve, y is 0 and x is equal to 1. Y took the place of tangent, and x took the place of sine. And yet I still wrote this backwards. So y took the place of tangent, so tangent's equal to 0, not 1. I had that backwards. Tangent is 0 at 0 degrees. Technically 360, but this is for all theta in degrees, so I don't necessarily need that one. It's also 0 at 180 degrees. Sine is 1 at 90 degrees. So, plus 360 degree k. K is an integer. Plus 360 degree k. K is an integer. And now let's chat about 90 degrees, because in all actuality, I should have plugged in, I should have checked, and I didn't do that with the first two. I got a little lazy, I'll be honest with you. Okay, at 0 degrees, sine is
They're not great.
0. Tangent is 0. Minus tangent is 0 is equal to 0. Yeah, that one works. 180 degrees, same thing's going to happen. 0 times 0 minus 0 is equal to 0. It's fine. But at 90 degrees, sine of 90 degrees is 1. But tangent of 90 degrees is undefined. Given that that is undefined, that becomes an issue for this problem, because you can't plug 90 degrees into this. So question 20 should be 0 plus 360 degree k and 180 plus 360 degree k, which by the way, you can simplify that down.
Hummingbird.
But this is what you get. It's one of those weird situations. We haven't run across a situation where all of a sudden we get an undefined value. And for some reason, the book still says it works, which makes no sense. Book's wrong. That's what happens when a bunch of college students make an answer key. Psh, they think they know so much. Just kidding. Okay. 23. Tangent squared theta plus 2 tangent theta plus 1 equals 0. Ooh, quadratic. X squared plus 2x plus 1 equals 0. We factored this a lot today. Two things that multiply to 1 and add to 2 are x plus 1 and x plus 1, which means x is negative 1. Tangent is negative 1 at... Okay, what are we solving for? So it just says solve. Why doesn't this one give an interval? That's dumb. Let's just do this between 0 and 360 degrees. Why not? We get to make a choice. Okay. 135 degrees. And negative 1 at 315 is the other one that works. Again, since these are a half circle away, we could simplify this down if we were doing plus all theta in degrees. We're not, so we don't need to. Okay, what was it, 23 through 25? Yes. 24. Cosine squared theta plus 3 cosine theta is equal to a negative 2. Oh, that's like x squared plus 3x equals negative 2. Okay. Get it equal to 0 by adding the 2 to both sides. Look for two things that multiply to 2 but add to 3. Those things are 2 and 1. X plus 2. X plus 1. X is negative 2. x is negative 1. Remembering it was never actually x, it was cosine. Cosine of theta is never going to reach negative 2, so that's not helpful. Cosine of theta equal to negative 1, on the other hand, happens at 180 degrees. (25) has sine of 2 theta minus cosine of theta equal to 0. Okay, identity. Sine of 2 theta becomes 2 sine theta cosine theta. Now, in order to solve this, do not subtract the cosines. They are not like terms currently. The first cosine is getting multiplied by both a 2 and a sine, which is the problem. The 2 isn't the problem. So, instead, if I want to solve this, I have to factor. I'm going to factor out a cosine. Leaves me with 2 sine theta minus 1 equal to 0, and split to solve. First one gives me cosine of 0. Next one, 2 sine theta minus 1 equals 0, would give me, add 1, divide by 2, sine of theta is 1/2. Okay. So, now that sine of theta is 1/2, and cosine is 0, cosine is 0 at 90 degrees, at 180 degrees. Sine of theta is 1/2 at 30 degrees and 150 degrees. Plug back in, they all work. Sweet. Last problem I gave you was question 38. I really like question 38. I know, y'all hate when I say that because you're like, scary problem. Benson loves it. It's really not too terrible. But it does have one of the things that messes with people that y'all seem to despise as if they are the plague, and that is fractions, which I love. Okay, cosine squared minus 3/2 is equal to 5/2 cosine. Kind of like x squared minus 3/2 is equal to 5/2 x. Not 5 over x. Benson, get it together. Okay. First thing I notice is this is quadratic. Therefore, I want it equal to 0. I'm going to subtract the 5/2 x and put it in standard form while I do it. So, x squared minus 5/2 x minus 3/2 is equal to 0. Now, to solve this, two things that multiply to 3/2 but add to a negative 5/2, I'm guessing many of you are like, Benson, what are you doing to me? Please stop. But we don't have to solve it like that. We can change these into integers because the problem is that we've got things being divided by 2. Well, let's undo it. Let's multiply by 2. But to multiply both sides by 2, if you multiply one thing, you multiply everything. Now, generally speaking, we still want it equal to 0, but 0 times 2 happens to be 0. 2x squared minus 5x minus 3 equal to 0. Doing some AC method. 2 times negative 3 is negative 6. Two things that multiply to negative 6 but add to a negative 5 are negative 6 and positive 1. Be careful of that. It is not negative 2 and negative 3. Those would multiply to a positive 6, which is not what I want. I have to do the rewrite, so 2x squared minus 6x plus 1x minus 3 equals 0. Factor by grouping. 2x, x minus 3, plus 1, x minus 3. Two x plus 1, x minus 3. Split and set equal to 0. Subtract 1, divide by 2, negative 1/2. Add 3, x is 3. But those were cosines. Cosine is a negative 1/2 at Brain, re-engage, please. Oh, what am I supposed to be solving for? I should probably check that too. All theta and radians. So cosine is a negative 1/2 at 2 pi over 3 plus 2 pi k, where k is an integer. Yes, I plugged these back in. Yes, they work. Okay, cosine is also a negative 1/2 at 4 pi over 3 plus 2 pi k, where k is an integer. Ow. And cosine will never be equal to 3. So that's our final answer.